Hello guys, in this video we are going to discuss the solution of the problem power set. So let us look at the problem statement. The problem statement says that given a string s of length n, find all the possible subsequences of the string in lexicographically sorted order. Okay, so what we need to do is, given a string s, we need to generate all possible sequences of this string. So all possible sequences are A, AB, ABC, AC, B, BC, and C. So we need to generate all possible sequences of this string, and then we need to sort it in lexicographically order. Okay, which means alphabetically order simply. And that is what we need to return. So let us try to understand the problem statement with the help of an example. So let us say ABC is the string which is given to us, and we want to generate all possible sequences of this string. So in order to generate all possible sequences, with each character, we have two options which is possible. So a character could participate in a sequence, or a character could not participate in a sequence. Well, what I mean is, so let us say ABC is the string which is given to us, and all the possible sequences are, so these are the sequences. With each character it is possible, so with each character the case is the character could participate in the information of the sequence, or it could not participate in the formation of the sequence. So what we can do is, we can say that here A will participate in the formation of the sequence, and then the remaining character or the remaining string which we will have is BC. In the other case, A will not participate in the formation of a sequence, and the string which we will be left with is BC. Okay, now let's move forward, and the same logic let us apply here also. Now the character in the string is B, so now B can participate in the formation of the sequence. If B chooses to participate in the formation of the sequence, then the sequence become AB, and the remaining character would be C. If let's say B chooses not to participate in the formation of the sequence, then the sequence will be A, and the character left will be C, or the string left will be C. Similarly here with the BC string, B has an option to form a sequence, or B chooses to participate in the formation of a sequence, and in the other case B chooses not to participate in the formation of the sequence. So this will be the case. Again, let's plug the same thing over here also. C will choose to participate in the formation of the sequence, and let us say C chooses not to participate in the formation of the sequence. Similarly here, C chooses to participate in the formation of sequences, in which case the sequence will be AC, and C chooses not to participate, in which case the sequence will be A. Similarly here also, BC and B. Here C, and then let's call this as an empty string. And towards the end, what we are going to do is, we are going to return these sequences. So these are the sequences which we have, and this is what we are going to return. Okay, excluding the empty string, of course. All right, so that's the generic idea about it, folks. Now let us see how we will be able to code this. So in order to code this, what we will say is that, let us say we have something called prefix with us. Okay, so let us say the prefix is empty as of now, denoted by double quote. And let's say we are at index 0. So we are at the first character, and the first character is making a decision whether it wants to participate in the formation of sequence or it does not. Okay, so now what will happen? Now let us see how we will be able to update these variables. Okay, so this is my prefix, this is my index, and this is the string itself. Okay, so now the prefix becomes what? The prefix will become here equals to A. The index will be 1. Okay, so let me just write down the index also. So the index is 1. In this particular case, the prefix is empty, right? Prefix is empty, and here the index is 1. Okay, now moving forward, in the next stage the prefix becomes this, right? So this is my prefix, and here the index is 2. Similarly here the prefix is this, So this becomes my prefix here, and the index is 2. Similarly, for these cases also, the index is 2 and the prefixes is respectively these. So this is my prefix, right? And here the prefix is empty string. Similarly, in the final stage, the prefix is this. Okay. So this is my prefix. Okay. And the index is 3. All right. So in each case is the index is 3. And if you see here, 3 is essentially, so 3 is equals to length of the string, right? So what I am trying to conclude from here is that once my index becomes equals to the length of s, then I know that the pattern I have, or the value which prefix hold, is a sequence, right? The value that prefix hold when index becomes equals to length is a sequence, and that is what. So now this sequence is something which we are going to store it in a variable. Okay. So that's the general idea about it, folks. Now let us see. So now let us discuss a pseudocode for this. So let us say that so let's say all subsequences we wanted to generate, or all sequences we want to generate here, and s is the string, p is my prefix, and I am right now at index this. Okay, and from here we want to proceed forward. Now if clearly if index exceed the length of the string, so then we will simply return from here. Okay, if index become equal to the length of the string, so if index is equals to the length of the string, then in such cases we know that the prefix contain a sequence. So here what we are going to say is, if prefix is not an empty string, so we have to exclude the empty string, then let's say there is a global variable which is sequence or sequences. It is a list. So what we are going to do is sequences we are going to append. All right, so this is my 4th, 5th, and after appending here we are going to return it, right? So now we have appended the sequences, and then we are returning from there. Otherwise we are in the mid cases, right? We are in the mid cases, and in mid case I have two options. Either the prefix, right? So this is my, okay, let me just look here. Okay, so this is my s, and let me call this all sequences as as. So here with this as, the string is there with me. The prefix has two options. Either the prefix remains as it is, okay, and then we have index plus 1 over here, and or the prefix will have the character, right? So s of index is a part of prefix, and then we are increasing the index. Okay, so that's from the discussion, folks. Now let us go back to our coding section and see how we will be able to code it. So the code looks something like this. So we will have a sequences with us. It will initially it's an empty list, and then we are generating all possible sequences here. The prefix is empty as of now, and the index we are starting from 0. Now, like we have seen in the explanation, if index is greater than length of s, then we are returning from there. If index is equals to length of s, then a sequence has been generated. Excluding the empty string, we are appending the sequences into the sequence which we have in the sequence array, and then we are returning from there. And then these two recursion, which is essentially whether s of index will participate in prefix or it will not. Okay, depending upon that, these are the two recursion we are calling. So that's about the code, folks. Now let us submit our solution. So our solution got accepted. So that's all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.